शुण तुम जो पढ़ा रिसर्च पढ़ा रिसर्च मैटर पढ़ा
आज्ञा
स्टैटिस्टिक्स पढ़ा तुम गोटे टॉपिक अच्छी प्रोजेक्ट बोली तुम प्रोजेक्ट गोटे अच्छी तुम प्रोजेक्ट तुमको सुविधा हम ये मेथोडोलॉजी गुड़ाक सब देख भल बुझिले केमती गोटे आरंभ कर लिख कौन कर सब सुविधा हम तुमको बतईदे पचर मुझे क्लास पर 5 मिनट बस तुम्हें मुझे बतईदे सब है
आज्ञा सर
ओके सर
अच्छा एनीवे मु तुमको जो कहूली रिसर्च मेथोडोलॉजी भारी इंटरेस्टिंग भारी हेल्पफुल आ खाली रिसर्च मेथोडोलॉजी नुहे आम स्टैटिस्टिक्स आ रिसर्च मेथोडोलॉजी ये कॉम्प्लीमेंटरी तेणु आम पढ़ा स्टैटिस्टिक्स just now I'll start statistics. So here I have already told you in the last class about what is statistics, what are the different types like parametric, non-parametric, and how these type of traits are helpful to us. And here I am again going to elaborate in detail about all these things. So non-parametric statistics, as I told you, it deals with statistics, non-parametric. So non-parametric statistics, it deals with statistics based on ranks of observations, not necessarily on scores obtained by interval ratio scores. So scores obtained by ratio or interval scales, they are not very much necessary for non-parametric statistics. Non-parametric statistics uses a scale other than this ratio scale or interval scale. And the normal statistics is defined to be a function of a sample that has no dependency on a parameter. Parameter, as I told you earlier, is an index of population. The interpretation doesn't depend on the population fitting any parameterized distribution. So statistics based on the ranks of observations, they play the central role in non-parametric approaches. Also, the non-parametric techniques don't assume the structure of a model is fixed. So about the scale and the model and the distribution, also normal distribution, the non-parametric statistics is very relaxing one. I mean, about the model, it doesn't believe in a fixed model. It doesn't have normal distribution, distribution of pre. So non-parametric statistics or these non methods are widely used for studying population based on rank order or data is given in ranking. Non-parametric methods make fewer assumptions. A statistics, as you know, refers to characteristic of a sample, such as average, like mean. A parameter, on the other hand, refers to the characteristic of a population. A statistics can be employed for either descriptive or inferential purpose, and one can use either of the two types, parametric or non-parametric. In these ways, the distinction between parametric and non-parametric statistics primarily based on 3-4 aspects. Number one, on the level of measurement. As a general rule, inferential statistics that evaluate categorical or nominal data and ordinal rank data are categorized as non-parametric tests, while those tests that evaluate interval data or ratio data are categorized as parametric tests. As I told you, the parametric and non-parametric statistics have the differences which can be outlined in these ways, like level of differences, assumed distribution, parametric statistics, assumed normal distribution, and non-parametric statistics, assumed no distribution. Any distribution will do. Normal or not normal. Non-parametric will do, but parametric only on normal distribution. On assumed variance, in the parametric statistics, the variance is homogeneous and the scores are homogeneous usually. In non-parametric statistics, it could be homogeneous, also it can be heterogeneous, also it can be both. With the type of data, the parametric statistics gets the data measured through ratio or interval scale, and non-parametric statistics gets the data measured through ordinal or nominal scale. Then usual central measure. In parametric statistics, the central measure is usually mean. In non-parametric statistics, the central measure is usually median. The benefits are also different. The benefits in parametric test, we can draw more conclusions. In non-parametric statistics, we can do simple conclusions and less affected by extreme scores. These are how we differentiate parametric and non-parametric statistics. Then I go to the assumptions of the parametric and non-parametric statistics. What are the assumptions? So now I am telling the assumptions of parametric test. Number one, there has been normal distribution. Normal distribution of the dependent variable, because we are observing the dependent variable. The level of measurement, interval data. The sample size usually 30 or more. In parametric, the sample size or the n number of cases should be more than 30. There is an independence of observation, because the observations are independent scores, except with paired data. The observations are mostly independent scores, independent observations. Fifth, the observations for the dependent variable have been randomly drawn. Sixth, equal variance among sample populations. The sample is taken from population. Sample population. The samples, they have equal variance. Lastly, the hypothesis usually made about numerical values, especially the mean. So we are coming to non-parametric statistics. The assumptions about non-parametric statistics. So here the fewer assumptions regarding the population of distribution. Sample sizes are often less stringent, maybe less than 30 also. measurement level by nominal or ordinal scale, independence of randomly selected observations. Primary focus is on the rank order or frequency of data. Hypotheses are posed regarding ranks, medians, or frequency of data. There are three major parametric assumptions which are and will continue to be routinely violated by research in psychology. That is level of measurement, sample size, and normal distribution. There are three major assumptions of parametric. Number one, level of measurement, that is interval ratio. Number two, sample size should be 30 above. Number three, there should be normal distribution. So here, these three on which we majorly distinguish between parametric and non-parametric statistical tests. They are level of measurement, sample size, and normal distribution of dependent variable. And I'm going to describe each one of them. The first one is the level of measurement. So the level of measurement is associated with the dependent variable of interest. Generally, for the use of parametric test, a minimum of interval level of measurement is required. Non-parametric statistics or techniques can be used with all levels of measurement and most frequently associated with nominal or ordinal level data. So now, the level of measurement, one is interval, or this is ordinal, and the level of measurement involves four types of measurement. So one is nominal data or nominal scale. It is the first level of measurement, nominal or categorical. Nominal scales are exclusively of two categories. With no implied ordering like yes or no, male or female, that are placed in one of these categories, like, and the numbers in each category are counted. The key to nominal level measurement is that there are no numerical values assigned to the variable. We cannot obtain the normal distribution of the data variable or the variable. So descriptive research in the health science would make use of the nominal scale often when collecting demographic data. For example, you are asking, does your back problem affect your employment status? You make yes or no as nominal data, nominal scale. Are you limited in how many minutes you are able to work continuously? Yes or no? That is nominal data. So the data, nominal data, is only involving category, either yes, no, or plus minus, or any category. The nominal data, nominal scale is the simplest scale and used only in non-parametric tests. Then we come to ordinal scale or ordinal data. The second level of measurement is ordinal data. The ordinal scale indicates an order, rank order. We can express in the form of rank or in an order. So ordinal data or ordinal level measurement gives us a quantitative order of variables. And here suppose the pain does not prevent me from walking any distance, lowest intensity of pain. So the lowest intensity or the highest intensity is order. So I mean, do not like, moderately like, very much like this, the order. So the ordinal data indicate the rank or order that is also used by non-parametric statistics. So here we are only saying more or less, more pain or more stress or more functional than this. But we don't say how much. We simply say what, more or less, not how. How much when you say that comes to interval scale. The third category is interval scale. It is the minimum requirement for the use of parametric statistics. This type of data is also ordered into mutually exclusive categories, but in this case the division between categories are equidistant. The only difference between interval data and ratio data is the presence of meaningful 0 point ratio scale. In a ratio scale we are having a true zero, but in interval scale we don't have a zero, only the equidistance gap. In an interval level of measurement, zero does not represent the absence of value. As such, you cannot say that one point is 2 times larger. The ratio scale is the highest scalable of measurement and provides the most information. The level of measurement is characterized by equal intervals and a meaningful 0 point. The ratio level measurement includes weight, blood pressure, etc. So now see, nominal scale is nominal or categorical. Ordinal scale is order or rank. Interval scale is only equidistant. Ratio scale showing equidistance, also a true zero. Suppose you can say A to B is equal to B to C. Or C to D. Suppose B to C, C to D like this. But you cannot see C to D is equal to twice of A to B. You cannot say. Because multiple things are gunana, multiplicity. Gunana harana jo kam karuchu. Multiple or division. We cannot do in interval scale because there is no zero, true zero. For example, in one fellow secured 50, another secured 100. So you cannot say that this fellow is 2 times brilliant than him. You cannot say. But in ratio scale, you can say, suppose you are having 3 feet height, somebody having 3 feet height, and a fellow 6 feet height. You can say he is 2 times or double of his height. You can say double because there is a zero. In interval scale, you cannot say double or half because zero is not there. So the height scale, weight scale, these come to the ratio scale. But other things like any score, any data, any achievement score that we're getting, that comes in interval scale. So now I come to the next one, that is we came to interval ratio data. We came to level of measurement. Now I come to sample size. The sample indicates a type of representation of population. We are not able to deal with the population so vast. So we take a part of the sample, a part of the population, to discuss or to represent the whole population. This part is called sample. And the sample size should be more than 30. When sample is small, they will be difficult for conclusion. Basing on a small sample, if you say, you make a conclusion, there can be type 2 error. It may not be correct, we say it's correct. Or it is correct, we say it is incorrect. So there may be type 1 error. So the errors will be there depending on the sample size. So when the size of the sample increases, the data, the result approximates towards population. When the sample size decreases, we say the graph, if you drag on that, what is simple cases, it will be asymmetrical. This may be also not normal. The more the sample size increases, it tends towards normality. So what type of sample we are taking in an experiment or study, that is more important. So parametric statistics, as I told you earlier, is applicable only when the size is more than 30. If it is applicable with the less 30, there may be some correction. So the next point is normality of the data. So when the data is normally distributed, then we, as we say that in case of parametric test, we ensure normal distribution. So here, in the sample size, the normality is also depending. So here, in case of normal statistics, we also use this normal distribution. There are many variables in addition that are normally distributed. Some variables like weight, height, strength, they are normally distributed. So here we find some traits in the population are so distributed that we say they are normally distributed. regarding height, you will find commonly people are having height within 5 to 6 feet. Then 6 to 7 very less. Then 5 to then less than 5 also very less. So now if you see the traits are distributed, look at the number. The highest number will be in the middle. That's like a normal probability curve. So the normality of the data indicates the applicability of parametric tests also. Now the question is, where can you use the non-parametric tests? The non-parametric tests can be used in 3 cases, in 3 categories. Tests of differences between groups, when the groups or samples are done independent samples. Then tests of difference between the variables, like independent variables. Then thirdly, tests of relationship between variables. So the non-parametric statistics can be used looking into these categories. Also, number one, it can be used to indicate difference between independent groups. Number two, to indicate difference between dependent groups by using the test like chi-square. We show difference between independent groups by using the test like Manute-New test, and between the dependent groups by using the chi-square or sign test. And thirdly, we show the relationship between variables in non-parametric statistical test by sometimes using Pearson R and Spearman's R, rank difference correlation, and Kendall's tau test. We use non-parametric statistics in descriptive statistics. Also, we use non-parametric statistics in problems and non-parametric tests. For example, 2 or more independent groups are there. So use non-parametric statistics like Manute-New test, Kuskal-Wallis analysis variance, all are used here. Also, we use this in problems involving paired observation. Use sign test. We also use this test, non-parametric, in randomized block designs or blocks. Also, we use rank correlations with Kendall and Spearman rank correlation. They estimate the relationship in non-parametric test. So, non-parametric statistics is used in all these debates. So, non-parametric statistics are frequently used. Let us see the advantage of this. So, the advantage of non-parametric statistics is like this. The non-parametric statistics test is less stringent. So, less conditions are required, unlike statistics test. Secondly, non-parametric procedures can sometimes be used to get a quick answer. I mean, parametric is time consuming. In non-parametric, we can use sign test, or you can do any median test to get a quick result, quick answer. Thirdly, non-parametric methods provide an air of objectivity. When there is no original data, this non-parametric methods can give data, bring data. Fourthly, a historical appeal of rank test. Is that it was easy to construct tables of exact critical values provided there are no ties in the data. So here, with the history of rank test, data with developing ranks, this test is very useful, and sometimes the data do not constitute a random sample from a larger population. The data in hand are all there. Standard parametric techniques based on sampling from larger population are no longer appropriate because there are no larger populations, there are no population parameters to estimate. So certain kinds of non-parametric procedures can be only applied to such data by using randomized models. Therefore, all these five cases, five categories, non-parametric statistics is more useful, more advantageous. There are also disadvantages. The major disadvantage of non-parametric statistics is content in its name because it is told as non-parametric. This means there is no parameter to describe, and it becomes difficult to make any quantitative statement about actual difference. The second advantage is that second disadvantage. The second disadvantage is that non-parametric procedures throw away information. The science state uses only signs. Rank test only use order ranks. Other informations are ignored because the information is discarded. Non-parametric procedures can never be as powerful as that of parametric counterparts or a parametric test. So now we cover the non-parametric tests. We now come to some types of non-parametric tests. So one of the non-parametric tests is man-Whitney U test. So this man-Whitney test is a two-sample test. In man-Whitney test, you take two samples and you say whether these two samples they differ or not. As you do in t-test, whether the means are different or not. Similarly, also here we take this in man-Whitney test, whether there is a difference or not. If at all there is a difference, the difference is significant or not. So man-Whitney test is a good way of measuring the difference between two samples, the two independent samples. So here we are having a null hypothesis. We assume there is no difference between two sets. If at all there is a minimum chance. Also there is scope for authority hypothesis. So here is called U test. And it has own its method. Step by step procedures are different also. So here you take the rank of both the data, both the groups combinedly. and then you apply this formula and you get this U value, and then you test the value whether significant or not. After computing this value significance, you can conclude whether the two samples they are different significantly or not significantly. There was another test, that Wilcoxon test for small sample. The sample is very small. Then we are computing by Wilcoxon masked pair single, or that is called Wilcoxon masked pair sign rank test. That is applicable when the sample is very small. And here we rank, combine we rank, then we take the different ranks, apply formula and get the value, then make the conclusion whether these two groups are different or not. So here, to show the or to test the difference between two groups, when the scores are measured, data is measured through ordinal scale, then you can use the Manute test, or you can use this Wilcoxon test. Then we can find out the difference in the two samples, whether significant or not. The Wilcoxon test can be used for a small sample or also for a large sample, and it has its own formula for finding out the value. Then you come to another test called Kruskal-Wallis test of variance. In the parametric statistics, we are having t-test, and the alternative to the t-test in non-parametric is your Manute test or this Wilcoxon test. Similarly, in parametric, we are having F-test or ANOVA or analysis of variance test. And in non-parametric statistics, we have the alternatives with variance test, that is called Kruskal-Wallis analysis of variance, or KW ANOVA, Kruskal-Wallis ANOVA. And here also, in the t-test, we are using two groups, and Manute test, we are having two groups. But here, in Kruskal-Wallis, we can have 2 or 3 groups, more than 2 groups also. And here we take the scores, we rank all the members in the entire data from smallest to largest, or we give combined ranks. Then the ranks for each samples. Then you calculate the Kruskal-Wallis statistics by giving the formula. The symbol is H. H means the ratio, Kruskal-Wallis ratio. From this we get the results, and then we speak about the different effects of the table. So we examine the significance of the test, given results. The ANOVA and Kruskal-Wallis ANOVA test can be compared also, how this is more useful. So here, as we could see that in the non-parametric statistics, two samples or two groups can be compared even if not normally distributed, even there is no interval or ratio measurement with the ordinal measurement, two groups can be compared, and the comparison could be involving U-test. And if there are more than two groups, you can also compare. You can also find out the effect of different variables. That is Kruskal-Wallis test. And next we come to another test, that is chi-square. And also other things like correlation. So in non-parametric test, we come across correlation, we come across other rank order test, we come across chi-square test, and other relevant tests to indicate the relationship between two groups. So one is the concept of correlation. As you know, correlation indicates relationship between two variables. When change in one variable accompany change in another variable in the same direction, we say that is positive correlation. If in opposite direction, we say about negative correlation or inverse relationship. And this correlation could be used by scattering or scatter plot, by scattering in the graph. A strong positive correlation goes in line. Almost the spots are crowded on line basis. And a weak positive correlation, the points are not crowded, they are scattered. The correlation as a method of relationship has certain characteristics. Number one, the correlation indicates the direction of relationship between two variables, whether it is positive or negative. Also, the coefficient of correlation always falls between -1 to +1, so the value is always ±1. Hardly larger the correlation coefficients mean stronger the relationship. The correlation measures or measuring through correlation can be used both in parametric and non-parametric statistics. The Pearson R or Pearson's product moment correlation belongs to parametric statistics. And the Spearman's rank order correlation, you can say it is Spearman's rho. The parametric is the Pearson R, but here it is Spearman rho. The Spearman rho, it assumes that it is measured on ordinal rank, ordinal scale. So in urban mathematics, the Spearman rank order correlation can be used. Also, one is Kendall's tau, a measure of correlation that is again used in the non-parametric statistics. Kendall U gives an easy explanation, easy answer to the relationship when the data is measured in ordinal scale. And thirdly, chi-square is another test which is also indicating relationship between two variables. And chi-square is a very useful method and very commonly used in non-parametric methods. The Kendall's rank order correlation or Kendall's tau or pi test is one of number of measures of correlation or association. Measures of correlation are not inferential statistical tests, rather descriptive states. So here in this Kendall rank order correlation or tau test, we rank the observations on the x variable from 1 to n and observations in the y variable from 1 to n. So arrange the list of n subjects know that the rank of the objects on variable are in their natural order. Similarly, in the y variable also. Then you apply the formula and whether ties, there are also different procedures. So by applying formula, we calculate the t value which indicates tau or correlation. So in the rank difference correlation, as you know, Spearman's correlation is the alternative of Pearson R. Pearson R is used when the data is in interval scale, but Spearman is used when the data is in ordinal scale. So let's come to the row or the Kendall's rank difference correlation or the rank order correlation. The row is an efficient measure when the data is not in a normality form. I mean, when the data is collected in non-parametric ways. The chi-square test, as I told you, is a very widely applicable test belonging to the non-parametric category. The chi-square performs two types of functions. One is the goodness of fit, the other is measure of independence. So we can see the goodness of fit basing on the following assumptions, like the number one, categorical nominal data are employed in the analysis. The assumption reflects the fact that the test data should represent frequencies per k mutually exclusive categories. Secondly, the data that are elevated consists of a random sample of n independent observation. Thirdly, the expected frequency of each cell is 5 or greater. So these are all assumptions of chi-square. And the chi-square test, we're having 6 steps here. Number one, in the chi-square test, we write the observed frequencies in column O. Then we write the expected frequencies in column E. Then use the formula chi-square is sigma O minus E square by E. We find the DF, degree of freedom, that is n by 1. Then we see the table and see the significance of the chi-square value. So significant indicates goodness of fit or independence. So here, the Kendall test, the rank order test, the chi-square test, they are all useful because they are indicating relationship between variables. So now I'm coming to the other, the third booklet, unit 1, that normal distribution. We have all been aware that the normal distribution is ensured in parametric test, but not in non-parametric test. So now the question is, what is normal distribution? Why do you call it normal? What is the concept of normal curve? The normal curve is a curve where if you compute the mean, median, mode, etc., there are three measures of random tendency: mean, mode, median. Hello, am I hard or not?
Yes, sir.
Oh, so here there are three. Actually, I was telling you about the concept of normal distribution and the normal curve. I told you there are three major characteristics. The normal curve significantly indicates that when you are having two groups of scores or we are having two distribution of scores and we compute the central tendencies like mean, median, mode. The mean means arithmetic mean. There are geometric mean, harmonic mean, arithmetic mean. But here the mean we refer to arithmetic mean. And here the mean, median and mode in a distribution. If these three tendencies coincide, if mean, mode and median they coincide, then we say that this is a normal probability curve. So here the normal probability curve, or theoretically you can say the probability of occurrence of a score is distributed naturally in a normal way. So the normal probability curve is a bell-shaped curve looking like a bell, and here in the normal probability curve the curve doesn't touch the baseline. So here we say the curve is bell-shaped, symmetrical and asymptotic. Bell-shaped means not conical. Symmetrical means both the sides. If you put on the mean, median, mode on the middle, and the curve becomes two half. It is symmetrical. Bilateral is symmetrical. Both the sides are symmetrical. And also, the normal probability curve is shaped in such a way the mean, median, mode they coincide, but the curve is not skewed. I mean, scores are not clubbing or crowding somewhere. It goes gradually from the extreme end towards the middle. And the curve, when puts down, comes down, it doesn't touch the baseline. That is called asymptotic. It runs parallel towards the end. It looks like going to parallel. Means asymptotic. And this, now the characteristics of the normal probability curve can again we analyze, we can discuss now in a new way. So we can say now, number one, the normal curve is symmetrical. Second one, the normal curve is unimodal. Unimodal means only one crowding. Score is crowded only in the middle, not anywhere. Mode indicates the crowding. Mode indicates the combination of scores, grouping of scores. In the normal curve, it is unimodal. Thirdly, the maximum ordinates occur at the center. Means the scores in maximum, they are counted in the center around the mean. The normal curve is asymptotic, as I told you. Asymptotic to the x-axis means it doesn't touch the x line. And 5, the height of the curve declines symmetrically. And 6, the point of influx when the curve is declining. So it doesn't stay straight, it bends gradually. This point of influx or the deviation or digression, the point where it digresses or the point of influx is 1 standard deviation distance from the middle. And next point, the total percent of the area of the normal curve is 100%. That we take 3 standard deviation. So within plus minus 1 standard deviation, we get 68.26% of cases. Then within 2 standard deviation, we get 95% cases. And 3, we get all 99 something or almost 100%. That is the distribution. The total area under the normal curve, number 8. Total area under normal curve may be considered 100% probability. And out of this 100% probability, we find 68.26 within 1 plus minus 100 deviation, 95.44% plus minus 2 standard deviation, 99.3%, 99.73% plus minus 3%, 3 standard deviation. So the probability of the scores are in percentage, that all they are compacted within the 3 standard deviation or the normal probability curve. The 9th characteristic is that the normal curve is bilateral. So 50% area in the left side, 50% in the right side of the mean. And 10th, the last characteristic of normal probability curve is that the normal curve is a mathematical model in behavioral sciences, especially in mental measurement. So we take it as a reference point, and while measuring different scores or different tests, we use this. So this is a mathematical model in or behavioral science, we take it as a measurement. So normal curve taken as a reference point. So here, these are all the characteristics of a normal probability curve. Through the normal probability curve, we can measure a trait which is normally distributed, and the test can be used to measure the trait is good or bad. And all these things are there through normal distribution, normal curve. We can get lot of benefits. The importance of normal probability, normal distribution is also there. That is you find many things, many traits, they are all normally distributed. Due to the individual variation, these traits are also varying. There is a variance, and you find extreme scores are the last and the middle common scores. So the traits are normally distributed. So the normal curve or normal distribution curve is applied in so many circumstances. So we can apply normal curve in 8 situations. Number one, to determine the percentage of cases within given limit or given score. Secondly, to determine the percentage of cases that are above or below a given score. Number one, within. Number two, above, below. Number three, to determine the limits of scores. That includes a given percentage of cases, like determining percentile rank. Number five, to find out the percentile value of a particular score of an individual, percentile value of an individual on the basis of percentile rank. And sixth, dividing a group into subgroups according to certain ability and assigning the grades. 7. To compare the two distributions in terms of overlapping. And lastly, we use normal distribution curve to determine the relative difficulty of test items. So normal probability curve is very much useful. So here, as I told you, in the practical problems, when you face the use of this, you can get the opportunity, get the scope. The normal probability curve is applied in so many cases, and it is a very, very useful curve in our in making conclusion. So divergence of normality. Sometimes we find the normal curve is also having its own deviations. The divergence of normality indicates a non-normal distribution. The divergence of normality could be in two ways. That is, it could be like skewness or kurtosis. Are you all able to hear me? Are you all able to hear me?
Yes.
Yes, sir.
Audible.
Sir, I think you are on mute. Sir, you are in mute.
Unmute yourself. Unmute yourself.
Sir, ଆପଣ mute ହେଇଯାଇଛନ୍ତି, unmute କରନ୍ତୁ.
Sorry, sorry. अरे କେମିତି ହେଉଛି ମୁଁ ଜାଣିନି ମୁଁ I don't know. ଆଚ୍ଛା, right.
ହଁ ହଁ
Now you got me? You got me?
Yes, sir.
Okay. I'm sorry. I do not know. Sometimes some mistakes are happening. So anyway, so the normal probability curve sometimes having its own deviation, or the normality is lost. How? These deviations are manifested in two forms. One is skewness, the other is kurtosis. The skewness indicates a distribution is said to be skewed when the mean and median fall at different points. So now you see, I told you earlier that the normal probability curve, the mean, median, mode they coincide. This means the mean and median, they are at one point. But now sometimes you find the mean and median, there are different points. This means the curve is skewed, or the balance is shifted to some side, or the point of center of gravity is shifted to one side or the other. If this balance is shifted to left side, then there is negative skewness. Shift to right side, then the positive skewness. So now no shifting. If the balance of gravity is on center, then there is no skewness, or skewness is zero. That is normal distribution or normal probability curve. So again I am saying the distribution is said to be skewed negatively or to the left when scores are masked at the high end of the scale. This means the scores are concentrated in the right side and gradually tapering, sloping to low side or left side. Then we say it is negative or negatively skewed distribution. In this case, what happens? The median will be larger than the mean. When the median is larger than the mean, or you can say that in the median towards the right and mean to the left, then you can say the curve is skewed to the left or negative skewness. In positive skewness, the distributions are skewed positively or to the right. When scores are marked low, means left is more crowded, right is tapering, sloping. Then you can say that it is positive skewness. So here you can say the mean is right to the median. So we can say that sometimes the median is more than mean, sometimes the median is less than mean, or median is right to the mean, median is left to the mean. This indicates the skewness. I mean, this indicates the type of skewness. So basically, skewness indicates concentration of score. When concentration is towards right and tapering to the left, we say skewed to left or negative. When concentration in the left side tapering to right, then we say it is rightly scaped, or it is skewed rightly to right side and positive skewing. So the positive means right side skewing and the negative means left side skewness or skewing. So here, apart from, and you see this, I told you earlier also, in case of normal distribution, there is no skewness or skewness is zero. And the skewness can also be measured. And next we can get another deviation for discussion, that is kurtosis. A normal probability curve is optimally kurtic. Kurtic means thickness or divergence in the height of the curve. That is thickness. Sometimes some pictures are conical, sharp conical. Sometimes some pictures are flat. So the normal probability curve is neither peaked nor flat. It is called middle size or optimum kurtic. That is called mesokurtic. Mesokurtic means medium kurtic. So mesokurtic is the normal probability curve. When the curve is more conical, sharp, or the sides of the curve are drawn to the center, then we call it leptokurtic. When the curve is flat and the sides of the curve are diverging from the center, we say it platykurtic. So we can say that the curve deviating from normal probability curve or deviating from normal distribution could be either leptokurtic or platykurtic. Leptokurtic means conical. Platykurtic means flat. So these are also calculated by different formula, and normally the normal probability curve is mesokurtic and the measurement is 0.26 Ku or kurtosis is 0.260, that is 0.26. So if the key Ku is greater than 0.26, then we say it is platykurtic. Less than 26, we say it is leptokurtic, because 0.26 is mesokurtic. And here the factors causing divergence in the normal curve, we could see the divergence like kurtic or skewed. And the factors causing this divergence is first selection sample. The sample is not perfectly or randomly chosen, and the sample is small. The sample is small or biased, then skewness is possible. Secondly, if the test is unsuitable or poorly made tests are used, then also asymmetry can occur. Thirdly, if the trait being measured is non-normal, skewness or kurtosis or both will appear when there is a real lack of normality in the trait being measured. Example, interest, attitude, other stability, all these things. You can't say there is any normality in this trait. So this could cause the skewness or kurtosis. And lastly, errors in the construction and administration of test also leads to, these errors leads to skewness or kurtosis. Suppose you are having this diversion. We could know the cause of diversion. And how can you measure the diversion? The diversion could be measured by different methods. So first of all, how to measure the diversion skewness? Skewness is measured by two methods. One is method of observation, the other is statistical method. The observational method is a method of detecting the directions of skewness by the inspection of frequency polygon. or looking at the tails of the frequency polygon of the distribution, we can say whether it is skewed or not. The other method is statistical method. We can know the skewness of the distribution by using statistical methods. So for the purpose, we use the measure of center tendency, specifically mean and median, to find out the skewness. By formula, the skewness is 3 mean minus median into 3. Mean minus median into 3 divided by standard deviation. And also the skewness is measured from percentiles. The skewness can be measured by P90 minus P10 by 2 minus P50, or 90th percentile minus 10th percentile by 2 minus 50th percentile. That gives the skewness. So you know percentile means centile percentile. Centile means 1 by 100. Percentile means so part of some percent of 100. I mean 50th percentile means 50 by 100. Centile means 1 by 100. So 50th percentile. So the 90 by 90 by 100. So 90th point percentile. So here P90 minus P10 by 2 minus P50, it will be the skewness. Then you come to kurtosis. Kurtosis is another deviation as I discussed, and kurtosis can be measured by the formula given like Ku, or kurtosis is equal to Q by P90 minus P10. So Q is quartile deviation divided by P90 means 90th percentile and P10 means 10th percentile. So you know the quartile deviation. So we are having central tendency like mean, median, mode, and we are having also the variability that is measured by range, average deviation, quartile deviation, standard deviation. And this deviation or the variability indicates dispersion of score around the mean, and the mean, median, mode. So dispersion of score around the central values gives idea about the variability, to which you call as measures of variability. Like range. Range is the distance between the lowest and highest score. That is range, the easiest or quickest measure of variability. Then we get the upper deviation, all the deviation from mean, irrespective of the signs, divided by n. Then you go to the quartile deviation, is equal to Q3 minus Q1 by 2, 75th percentile. Then here you can have the 50th percentile, on the other hand you can say. Or you can get to the other method, that is standard deviation, where you take the deviations and you square it to ignore the signs. Then you again divide by n and root over. So there are 4 methods to measure variability. And easiest was range, then standard deviation, then average deviation, then quartile, last is standard deviation. Standard deviation is more usable, is a more stable method of variability, and used frequently in parametric statistics. and other deviations could be used in the non-parametric statistics. And the kurtosis, as I told you, can be measured from quadrile deviation divided by 90th percentile minus 10th percentile. So here we end the normal distribution. Now I come to the mean and the significance of mean difference. So here, before I come to this chapter, I must ask you whether you are feeling comfortable or not. Whether you are feeling comfortable or not. And any question you will be asking to me, any doubt accumulating, any type of uh, question answering if you like. Dr. Rucha, will you ask me anything? Dr. Rucha, will you ask me anything? Santanu, will you ask anything?
Nothing, sir.
Do you want to me ask? Do you want to ask me anything?
Nothing, sir.
Nothing. Very good. Then Samarpita, will you ask me?
No, sir. Thank you, sir.
Okay, good. Bhagyasri, are you asking me anything?
ସାର୍ ଷ୍ଟାଟିଷ୍ଟିକ୍ସ ଉପରେ କିଛି ନାହିଁ କିନ୍ତୁ ରିସର୍ଚ୍ଚ ଉପରେ ଗୋଟେ କ୍ୱେଶ୍ଚିନ୍ର ଆନ୍ସରଟା ଟିକେ ଦରକାର ଥିଲା।
କହିଦେବି ମୁଁ। ଶୁଣ ତମକୁ ସବୁ କହିଦେଉଛି। ତମେ ସବୁ ରିସର୍ଚ୍ଚ ପାଇଁ ଆହୁରି ଥର ହେବା ପାଇଁ ତମେ ସବୁ ଦେଖିବ ତୁମର ଗୋଟେ ଅପସନ ଅଛି ପ୍ରୋଜେକ୍ଟ ଅର୍ ପଜିଟିଭ ସାଇକୋଲୋଜି। ଜାଣିଛ କି ନାଇଁ?
ଆଜ୍ଞା
ଆଜ୍ଞା sir.
ସେକେଣ୍ଡରେ କି ପଢିବ ଗୋଟେ କ'ଣ ପ୍ରୋଜେକ୍ଟ ଅର୍ ପଜିଟିଭ ସାଇକୋଲୋଜି। ବହୁତ ପିଲା ଡରିକିରି ପ୍ରୋଜେକ୍ଟ ନିଅନ୍ତିନି, ପଜିଟିଭ ସାଇକୋଲୋଜି ନେଇଯାଆନ୍ତି, କିନ୍ତୁ ପ୍ରୋଜେକ୍ଟରେ ବହୁତ ନମ୍ବର ମିଳେ। ପ୍ରୋଜେକ୍ଟ କଲେ ତୁମର ଗୋଟେ ମାନେ ଷ୍ଟାଟିଷ୍ଟିକ୍ସ ଆଉ ରିସର୍ଚ୍ଚ ଉପରେ ଗୋଟେ ରିଚ୍ ରହିଲା। ତୁମେ ଜାଣିପାରିବ ତୁମେ କ'ଣ ରିସର୍ଚ୍ଚ କ'ଣ, ଗୋଟେ ବହିଟେ ଲେଖିବ, ତମର ରହିଲା ସେଇଟା ତମ ସମ୍ପତ୍ତି ହେଇକିରି ଫ୍ୟୁଚରରେ ତାପରେ ପିଏଚଡି କରିପାରିବ, ଫ୍ୟୁଚରରେ ପେପର ଲେଖିପାରିବ, ନୂଆ ରିସର୍ଚ୍ଚ କରିପାରିବ। ତେଣୁ ପ୍ରୋଜେକ୍ଟ ପାଇଁ ଅପ୍ କରିବ। ମୁଁ ଦେଖିଲିଣି ବହୁତ ପିଲା ନେଉଛନ୍ତି ପଜିଟିଭ ସାଇକୋଲୋଜି, ମାର୍କ ବସ ଭଲ ଆସୁନି। ମୋ ପାଖରେ ତ 200 ପାଖରେ ପିଲା କଲେଣି ପ୍ରୋଜେକ୍ଟ। ପିଲା ବହୁତ ପ୍ରୋଜେକ୍ଟ କରନ୍ତି, ମୋ ପାଖରେ ମୁଁ ଦେଖିଛି ଭଲ ନମ୍ବର ପାଆନ୍ତି। 90, 85, 86, 89, 92 ଏମିତି ପାଇଛନ୍ତି ନମ୍ବର ସବୁ। କିନ୍ତୁ ପଜିଟିଭ ସାଇକୋଲୋଜି ନମ୍ବର କାହିଁ? ତେଣୁ ତୁମେ ଯଦି ପ୍ରୋଜେକ୍ଟ କରିବ, ତେଣୁ ୟୁ ହାଭ୍ ଟୁ ଅଣ୍ଡରଷ୍ଟାଣ୍ଡ ଦି ରିସର୍ଚ୍ଚ ମେଥଡୋଲୋଜି। ଭାରି ସହଜ, ତମକୁ ନୂଆ ନୂଆ ଲାଗୁଛି ବୋଲି ଟିକେ କଷ୍ଟ ଲାଗୁଛି, ବଟ୍ ଇଫ୍ ୟୁ 2-3 ଥର ପଢିବ ଯଦି, ନହେଲେ ଆଗ ମୁଁ କହିଦେବି ତୁମକୁ କେତେବେଳେ ସବୁ ପୁରା ସହଜ ଲାଗିବ। ଆଉ ଯେତେବେଳେ ପ୍ରୋଜେକ୍ଟ ତିଆରି କରିବ ବେଶୀ କଷ୍ଟ ନୁହେଁ, ଭେରି ଇଜି। ଟିକେ ଦୌଡ଼ିବାକୁ ପଡିବ, ଟିକେ ୟୁ ହାଭ୍ ଟୁ ସ୍ପେଣ୍ଡ ଲିଟିଲ୍ ମୋର ଅଲସୋ, ବଟ୍ ଆକ୍ଚୁଆଲି ଇଜିଲି କରିପାରିବ ପ୍ରୋଜେକ୍ଟଟାକୁ। ତେଣୁ ତୁମେ ସବୁ ଚେଷ୍ଟା କରିବ ଯଦି ପ୍ରୋଜେକ୍ଟ କରିବା ପାଇଁ, ତମର ମାନେ ଦି ଆଡୁ ଲାଭ। ଯେତେବେଳେ ମନକୁ ମନ ଡାଉଟ୍ କ୍ଲିୟର ହେଇଯିବ, ପ୍ରୋଜେକ୍ଟ କଲା ବେଳେ ମନକୁ ଏଇ ଯୋଉ ରିସର୍ଚ୍ଚ ମେଥଡୋଲୋଜିରେ ପ୍ରୋବ୍ଲେମ ରହୁଛି ତମର, ମନକୁ କ୍ଲିୟର ହେଇଯିବ। ଦ୍ୟାଟ୍ ଇଜ ପ୍ରାକ୍ଟିକାଲ ଏକ୍ସପୋଜର। ବଟ୍ ଏନିୱେ ତୁମର ଡାଉଟ୍ ଯାହା ଅଛି ମେଥଡୋଲୋଜି ଉପରେ ପଚାରିବ, ମୁଁ କହିଦେବି। ୟା ପରେ ବି କାଲି କହିଦେବି। ହେଲେ କାଲି କ୍ଲାସ୍ ଅଛି, କାଲି କ୍ଲାସ୍ ସରିଲା ପରେ ସବୁ ତୁମେ ଅଧଘଣ୍ଟେ ମୁଁ ସମୟ ନେବି, ତୁମେ ସବୁ ପଚାରିବ କୋଶ୍ଚିନ୍ ମତେ।
ଆଜ୍ଞା
ହେଲା?
ଆଜ୍ଞା ସାର୍।
ଏନିବଡି ଏଲ୍ସ? ମହେଶ୍ୱର, ତୁଷାର?
No, sir.
No question, right? Okay, anybody else? Madhusmita? Oh, she left. So anybody else, you can ask me question. No, then I'm going to significance of mean difference. So it is a very difficult chapter, very difficult to grasp and understand also. Only listen carefully. Suppose now you all be free in easy mind, blank mind. You listen to me. I have told you that statistics uses sample to study on behalf of population. So we use sample to study about population. We collect sample from population. So how we collect sample, that is important. I am giving an example. Nowadays there is election propaganda going in Bihar. Suppose we want to know, you are very eager to know who is winning. Can you reach all the Biharis, all the people of Bihar? Can you reach and to get the opinion? Not possible. If you try to reach everybody, then not only this election, another 2-3 elections will pass away because the numbers are so vast. So what you do? You take a sample. So the sample you take to know the mind of the population. So how do you take sample? So how correctly you choose a sample? Suppose you take a sample from urban area, then rural mind is not infecting. Suppose you take from a religious area, one religion, then the other people's mind not infecting. So you have to choose a sample in a correct way. So now the question is, suppose there are 500 persons in a population. Suppose there are 500 persons or 500 students in a school. You want to make a study on the school. You cannot go to make a study on all the 500. So you would take 10 students or 20 students as a sample and make a study. So now how can you get it? From the 500 students, like 5 classes are there. There are 5 classes. 6, 7, 8, 9 classes there. So sorry, 7, 8, 9, 10. 4 classes are there. There are 4 classes are there. 500 students. How can you measure about the students' impression or students' character, students' behavior? So you want to take a sample of 20. 20 means 5 from each class. So how these 5 you collect? It must be randomly collected. It must be irrespective of any bias. So if the sample is collected randomly without any bias, then what you can say? That the sample will be similar to that of population. Suppose now in the school there are 500 students, and in the school in each group you are having 10 students. So how many samples are there? 50. If in one group you have 10 students, total 500. So you will have 50 groups. So if the 50 samples are randomly selected, then the means of each sample will be equal. Or means of each sample will be almost equal. Could you get me or not? Again, I'm coming. Suppose there are 500 students, and out of 5 you have taken 5 samples. So 5 samples are 5 sample means. There are 5 type of means and 5 samples. So if the 5 samples are correctly collected from the population, then what happens? Then all the sample means will be almost equal, or the all sample means will be more or less same. So now the deviation or the difference between sample mean and the population mean will be less. When the sample size increases, it becomes larger, then its mean and population mean will be almost equal. When sample becomes small, then the mean of the sample and the population mean will be more distant, or will the difference will be more. So that is called sample means taken from the population are also normally distributed. Now you see, we are taking in each sample 10 persons. There are 500 cases. So 500 cases means there are 50 samples. You will find all the 50 sample 50 means. So the sample means will also be normally distributed. And the sample means they are different population mean. So that mean difference is sample error. And the central limit theorem is there, which indicates these sample means they have differences from population mean, and that differences also will be normally distributed, and thereby we get sample error, standard error of difference. So one is standard error, other is standard error of difference. So now see, in a population, when you take the variability index like standard deviation, what is standard deviation? The deviation of the score from the mean. Oh, deviation, yes, deviation score from the mean. So that is called standard deviation. When sample mean is deviating from population mean, that is standard error. When sample mean differences are deviating from the mean, population mean, that is standard error of mean differences. So SD, standard deviation, SE, standard error, SED, standard error of difference. There are three concepts. So standard deviation, standard error of difference. Are you clear about the concepts? It is naturally a bit hard. Are you understanding this? Samarpita, are you able to follow it? Samarpita, are you following me? Rucha, are you following? Are you not there? Santanu, are you following?
Yes, sir.
And the girls are not responding. Why are they quiet? Matabdi, are you following me?
Yes, sir.
Slowly. I mean, there is still some doubt in you. Yes, I know. There will be doubt. The concept is very difficult. I will repeat if you like. Do you want me to repeat it?
No,
Yes, sir. Yes, sir. Please repeat.
Yes, that's good. I don't mind repeating it because I'm fond of clarifying your doubts. The concept must be clear.
Yes, sir.
So I love my students all the time because I want my students to know, so they will be thorough. So now listen to me. You know, the variability is measured, as I told you, by 4 methods. Variability means dispersion or spreading of scores around the mean. And this variability is measured like range, average deviation, quartile deviation, and standard deviation. And standard deviation is used in mostly in parametric statistics, and standard deviation used in population studies, and the in mean we say in sample, and we say mu in population. And you see here the standard deviation in a sample is indicating how the sample is deviating from population. So now the sample deviating from population is standard deviation. Then sample means deviating from population mean is called standard error. And the differences in sample deviating difference in sample mean deviating from population mean is called standard error of mean differences. So now again I am saying there are 500 students in a class, or you can say there are 10 students or 100 students in a class. You are in a class having 100 students and we are collecting 10 samples. Each sample is having 10 students. So the total number of samples is 10. The total number of n number of cases is 100. So in the 100 number of cases, population is 100 because population means total number. In a classroom, there are 100 persons. So the population is 100. So the population is 100 and the sample is 10. The sample 10 deviating from population in terms of standard deviation. And all the 10 samples, they are having 10 means. And their means are deviating from the population mean. And the sample mean deviating from or different from population mean. That is called standard error. Now see, the score deviating from mean, standard deviation. The sample mean deviating from population mean, standard error. And the sample means they are having differences. 1 different from 2, 2 different from 3, 3 different from 4. There are many difference. That difference between the sample means is also deviating from population mean. That is standard error of mean difference. So 3 terms are there: standard deviation, standard error of difference. So these 3 terms indicate the deviation of score from the mean, the deviation of sample mean from the population mean, the deviation of the differences among sample means from population mean. Could you get me or not? So these are 3 concepts of variability: standard deviation, standard error, and standard error of difference. Standard error mean difference, like that. So here, these 3 concepts are taken to be used for studies like t-test. In t-test, we are taking 2 samples. Suppose you are taking out of 500 students or 100 students, you are taking 10 samples, and we are testing with 2 samples only, not on the other 8. Only 2 samples you are taking. So the 2. So because now see, the class has 100 students, and you have randomly taken 2 groups, 10, 10, 20. Then what do you expect? When they are randomly taken, both the samples should be identical with their scores, with their means, with their median, isn't it? Suppose the sample means have some difference. Now we want to see this mean difference between 2 samples is significant or not. Now the question is, if significant, suppose the sample means are different and the difference is significant, then what will say? They should not be significant because they are coming to the same class, randomly chosen. There should be no difference. But if there is difference, we will say that they are not from the same population. Maybe one group is from school, the other group from a different school. Would you get me or not? Since two samples are taken from the population randomly, then we expected that these two samples will be similar in their performance. Their mean will be similar. Their ST will be similar. And they will not, their difference, if there is a difference in their mean, this difference will not be significant. It will be by chance. And this difference, this mean difference is significant or not, we have to measure by a formula. And this is called t-test. And t-test indicates whether these two sample means are different or not. The significance of difference between two means is telling about t-test. If the difference between two means is significant means level of significance 0.05, 95 confidence interval 95%. So if this difference between two means is significant, then we have to say that there's two sample means belong to two different population, not the same population. Would you get me or not? Sandhyarani, are you clear? Or again, I will give another example.
No, sir. Yes. Now it's clear.
I can give another example. So, Samarpita, are you hearing? Samarpita, your face is there, but you're not responding. Satabdi, are you there?
Yes, sir.
Are you clear? Or to give it another
Yes,
example?
sir.
So now also giving another example because many of you are not. Yes, anybody? Jaram? Or Tushar?
It's,
Are you all clear?
it's fine, sir. It's fine. Please
It's
go on.
fine, right? Good. Still then, because many persons are afraid of statistics. I'm giving a small example to be very clear more. Suppose in your family there are 6 persons. There are 6 persons in the family, and you are taking two groups, 3, 3. In 3 persons, 3 groups, you is a sample, and the 3 group sample has its mean also. Sample 1 from the family, same family. Sample 2 from the same family. The sample 1 has a mean. The sample 2 has a mean. If they are from the same family, what you are expecting? Both the means will be equal. Is not it? If not equal, maybe any difference due to chance. But if the difference is significant, this means sample 1 of one family, sample 2 of another family or another family, not from the same family. Isn't it? So that is the view here. So here we take the t-test. T-test is a test of significance of difference between the means. If the difference in the means is significant, then we have to interpret that they are either not selected randomly, they are biased samples, or they are coming from different population. And here we always start with the null hypothesis, which means there will be no difference. Now you see, since two groups, sample 1, sample 2, from the same family, there will be a hypothesis, null hypothesis. This means there will be no difference. because from the same family they have come. There will be no difference. Null, no. If there is a difference, the difference is by chance. So H0 or null hypothesis is there, which means there is no difference, or if difference, it is by chance. That is called H0. H0 means hypothesis indicating zero difference. H1, if null hypothesis is not correct, there is difference, then we accept H1. H1 is alternative hypothesis. So here the t-test is a test indicating the difference whether it is significant or not. So thereby I want to say briefly about standard error and the standard error of difference. The central limit theorem is there, which indicates samples taken from a population, they have their differences, and that differences are also central normally distributed. That is called central limit theorem. So here the difference is taken as standard error of difference, SED. So the mean we are counting from a population is now indicating that they will be similar, or the mean will be if not same, similar or minor difference, and that difference is measured in terms of SED. So now here, yes, anything. So now now I'll tell you we know the parameters we are measuring here. The concept of parameters and statistics and the simple representations, and the number one is estimate, the statistical measurement, that is methods of contingency or methods of variation. They are actually estimates, or here you can say that the estimates or statistics, they are only the indicators of some values. And also we have parameters. As you know, parameters are population values, or the measures of population are parameters. And here the significance of level of significance of the statistics, that is measured through sampling error and standard error, I have told you. And here the T ratio is the ratio, that is distribution of statistics, that is measured by T is equal to M minus M population, but by ACM. You see the book, mean minus population mean by standard error of mean. And you go later, you see standard of difference also. So now this we are going to test the significance of difference. So both the samples would be small or large. So also the measures could be independent or dependent. So now looking into that, the formula is also different, and the value is compared, the signal value compared with respect to degrees of freedom. So I have very less time, so I am only telling you one thing: degree of freedom. Degree of freedom means in what cases, in how many cases you are free. Suppose you see one thing. Suppose you are having 10 chocolates in your hand. Now see, suppose you are having 10 chocolates in your hand. So you are giving 4 chocolates. You are bringing in the pocket 4 chocolates to a person. So one person went to you, you gave 4 chocolates. Another went to you, you gave 4 chocolates. The third man gave one to you. Can you give 4 chocolates? No. So here you are only give to 2, you are limited. So this means when you are acting, you are out of in 3 cases, you are free in 2 cases. In third case, you are limited. Because looking at the totality, you are limited. So the degree of freedom means, so in how many cases you are free? There are 3 cases, but in 2 cases you are free. You can give as many. But in third case, you are not free. So now, if there are 3 cases, n is 3. So degree of freedom would be 3 minus 1, means 2. Similarly, there are 20 cases. So you can be free in 19 cases. But in one case, last case, you can't be free. So 20 minus 1 is degree of freedom. So always the degree of freedom is calculated as n minus 1. So here, this p value is the value of difference between 2 means, and it tested against standard of difference, and this value is tested on significance by looking at the degrees of freedom. So I will clarify in the next class, right? So we can now be free. The class is over. Now you can ask me anything you like. So tomorrow I can clarify further if you like. I know you must be carrying many doubts in your head. The statistics are not as simple as I say, because you are the freshers. But I would be suggesting you to take projects so that you can apply statistics, you apply certain methodology, you learn something. You feel like passing MA. I remember in our days, special paper was always getting priority in statistics and research methodology. So nowadays, schools are getting easy. They want just to read and give any mark and get pass over. So passing is as simple as you say now, but getting a good mark and getting a position division counts more. Anyway, any question from any of you? I would solicit your questions. I would like to be one with you in sharing discussion. Zeram, from which place you are?
Sir, I am from Baliguda.
Baliguda. All right.
I am from Baliguda now. I am a priest.
You are a?
I am a priest.
Oh.
So I am from Baliguda. So I am just, I had a free program. I had gone to
Acha,
Kerala.
acha.
So I missed two classes. So,
Acha.
okay.
Oh, you can ask for any help also. I can do it. I can help you.
Sir, one thing I want to ask you,
Yes.
is there possibility of what is called, whatever it is taught, can be shared in the WhatsApp group or something else like that?
I mean, you want to have offline.
ସାର୍ ରେକର୍ଡିଂ ମିଳିପାରିବ କି ଆମେ ଯୋଉ କ୍ଲାସ୍ ଗୁଡାକ ବର୍ତ୍ତମାନ କରୁଛୁ?
I don't know. ରେକର୍ଡିଂ ତ ବହି ପଢା ହଉଛି, ବହି ଦେଖିକି କୁହା ହଉଛି, ତମ ବହି ତ ତମ ପାଖେ ଅଛି। ତମେ ତ ବହି ଅଛି ନା ଭାଗ୍ୟଶ୍ରୀ, ତମ ରେକର୍ଡିଂ କଣ ଦରକାର?
ଆଜ୍ଞା ବହି ଅଛି ଯେ, କିନ୍ତୁ ମାନେ ଆପଣ ପଢେଇଲେ ସେଟା ବେଟର ଲାଗୁଛି, କନସେପ୍ଚୁଆଲାଇଜ ଭଲ ଲାଗୁଛି ତ।
ନାଇଁ ତୁମ ଏନିବଡି ହବ, କାରଣ ସବୁ ବହିରେ ପଢିଲେ ବେଶୀ ବୁଝି ହୁଏନି, ମାନେ ରାଗ ଲାଗେ ପଢିବା ପାଇଁ, ଏଇଭଳିଆ ବୁଝି ତ ହୁଏନି ଆଉ।
ଆଜ୍ଞା
ତମକୁ କହିଲେ ବୁଝିଲେବେ, ମୁଁ ତମକୁ ଆଉଥରେ ବି କହିଦେବି।
Sir, one thing. Excuse
ହଁ
me, sir. Sir, they
ହଁ
can
କହ।
get the videos of these sessions in the website of RC Bhubaneswar. So we are uploading all the links using the link, they can make use of this video as and when they require, as per their convenience as well.
Thank you. Sir,
Okay,
the
Yes.
good.
books, our postal address been given. So
Yeah.
if it is the books are been sent, it is better because if they are sent, they have sent. So far I have not received, sir.
Okay, do one thing,
No,
write a mail indicating
more
your name
one.
and enrollment number, write a mail to RC Bhubaneswar, we will take care of it.
Okay, thank you.
Okay, so now listen. I have to tell you very honestly one thing. तुम सब निजे पढ़ बहिरू जो डाउट में क्लियर कर लियो तो किए पढ़ी रेकर्ड कौन डोंट फॉलो दैट कहीं ना निजे पढ़िले तुम क्लारिटी सृष्टि हम यू विल बी कन्सिस्टेंटली क्लियर तुम जो बुझी पारुन से तुम यदि पचार तुम क्लियर हो किंतु का रेकर्ड पढ़दब क्लियर हो पारनी रहा माइंड डाउटा तो पाठ बुझिक लिखा बड़ा इंपोर्टाट व्हाट आई मीन कारण मुझे तो नबुझे किसी बसेनी आई ऑलवेज बिलीव इन कन्सेप्चुअल क्लारिटी पिला शुण सब मुझे मो बैकग्राउंड हेलो मुझे साइंस स्टूडेंट
हाँ सर
हैं
हाँ सर आप जोड़ा कहते हैं एब्सोल्युटली करेक्ट आम जिते
शुण शुण मुझे कहूँ शुण
बही आम जहाँ भी
अनुमति कहूँ
हार्ड कॉपी जहाँ आम थे
मुझे मो अनुभूति कहूँ हाँ
आपण
कह कि मुझे शुण मुझे कहूँ शुण मु साइंस रु आसी पढ़ुली मु साइंस स्टूडेंट थी मेडिकल पाइक भी आई पारे मेडिकल पढ़ी मेडिकल पढ़ी पारे आम आसली हिस्ट्री पढ़ली ये भल करी बहुत फास्ट ऑल्सो
कहवाक चाहूली बोले आम तो निजे पढ़ले मुझे बुझी पार्बन कारण एटा
शुण मुझे साइकोलॉजी आसली गोटे कथा कल देखिली मुझे लोक पढ़ु बही बुझुना बेसी तेणु बुझिली भाविली जहाँ बुझी दैट इज फाइनाल तो मुझे नोट फोट करे सब कनसेप्ट क्लियर बुझे मु तेणु मोर आई बिलीव इन कन्सेप्चुअल क्लारिटी से मुझे फास्ट हो गली तेणु मुझे एक्चुअली बिलीव करे जो मैंने कन्सेप्चुअल कन्सेप्ट क्लियर से माने परीक्षा भल करेंगे आ लिखापी कौन कौटे लाइन लिख नॉट वेरी मटेरियल but write correctly and who can write correctly those who are conceptually clear तेणु क्लियर हो पाई बही पढ़ एवं डाउट को लिस्ट करो 1 2 करी डाउट को पचारो हाँ कह हैं कौन बुझ पारनी मु कौन है कह शुणा गलानी अरे कह
तांका वॉइस टा क्लियर आसुनी सर
मो वॉइस है
तांकर माने जे कहउछंती माने जेराम
हाँ क्लियर आसुनी हाँ कह हाँ कहो ना कहो आई एम देयर हियरिंग
एब्सोल्युटली करेक्ट सर हम तो कांसेप्ट जो हम कांसेप्ट क्लियर है बोले सर हमें आउ किसी हमें करि पारुनो कि हमें मार्क जाको मने भलो हमें लिखि पारबोनो कि बुझी पारबो तने कांसेप्ट होसी सबरो बड़ विषय जा के क्लियर हेले सब किछ हमें बुझी पारबो आ हमें भलो भी करि पारबो हमें
concept clear no hole you should be clear in concept then only you can really understand psychology ei khali ei satisfaction any bata ho mu to I encourage to be clear in concept जेबे पचारिबो जेते बळे मु कहिबि तुमको मते भल लागे
सर स्पेशली रिसर्च और स्टैटिस्टिक्स सब्जेक्ट टा टिके बहुत हार्ड टिके टफ लागो छ तो
सम तमे तो मु देउची तमे तो जेडा सब भल जेडा को बस किसी कार कंप्लेंट नाही आउ समते कहि सारे बुझी परनु आउते कहंतु यू आर ऑल वेरी गुड स्टूडेंट्स नॉलेज तो कंप्लेंट है
हमें बहिरु पढ़ी की जते बळे डाउट होबो जदि मोर डाउट हो मु आपन तो कांटेक्ट नंबर नोट डाउन करिछि मु आपन कॉल
वेरी गुड आई विल वेरी हैप्पी मते तुम डाउट पूछले आई विल बी वेरी हैप्पी कारण मु चाहे जे समस्ते बुझंतु भल करी
आज्ञा पर्टिकुलरली सेही रिसर्च और स्टैटिस्टिक्स टा टिके टफ लागुची।
वेरी मु जानुची धाउतिबो तमरो साइकोलॉजी रे जेते पाठ अछि खाली स्टैटिस्टिक्स नै एनी पाठ पचारले मु कहि देबी।
आज्ञा सर
मु चाहे जे मु पचारे पिला सब कहीं पढ़ुछ तीनोटी प्रकार आंसर पाए किए कहे बहुत नंबर पाई किए कहे बहुत इंटरेस्टिंग सब्जेक्ट पढ़िया पाई किए कहे मु पाए गुड डिवीजन बुझल तेणु बहुत लोक कहते हैं भारी इंटरेस्टिंग लगे पाठटा तेणु मुझे कहूँ यू फील इंटरेस्टिंग ओनली व्हेन यू अंडरस्टैंड बुझल तेणु तुम सब भल कर बुझ आ मुझे तुमको कहबी जब तुम प्रोजेक्ट नियो आई विल हेल्प यू आई विल गाइड यू
ମୋ
ସାର୍
क्वेश्चन
तुम्हारा
डाउट
बहुत
थिला।
हेलो
हेलो
ସାର୍
हाँ कह
ସାର୍
स्टडी
ମୁଁ ତ
रिलेटेड
ପ୍ରଥମ କେତେ
डाउट
କ୍ଲାସ୍ ମୁଁ ମିସ୍ କରିଛି ତେଣୁକରି
हाँ
ଆପଣଙ୍କର ଟିକେ ଇଏ କଣ୍ଟାକ୍ଟ ନମ୍ବରଟା ଆପଣ ସେୟାର କଲେ କି ଆମେ ଟିକେ ବେନିଫିଟ ଏମିତି ତ ସେୟାର
ମୁଁ
କରିଛ ଯେ ତଥାପି ମୋ ସାର୍
ମୁଁ ନମ୍ବର ଆଉ ଦଉଛ ଶୁଣ ନା ନମ୍ବର ଟିପି ଦିଅ
ହଁ
98610
ସାର୍ କୁହନ୍ତୁ
98610 98610
9861
ହଁ
ହଁ ସାର୍
98610
ସାର୍
32210 32210 ହେଲା
ହଁ ସାର୍ ଥ୍ୟାଙ୍କ ୟୁ ହଁ ସାର୍
ହଁ ତମେ ଯେବେ ଫୋନ କରିବ ମୁଁ ବି ଇଭିନ୍ ରାତି 12ଟା ପର୍ଯ୍ୟନ୍ତ ମୁଁ ଫ୍ରି ଥାଏ ଯେବେ ଫୋନ କରିବ
ଥ୍ୟାଙ୍କ ୟୁ ସାର୍
କାରଣ ଏବେ କାଉନସିଲିଂ ପଚାରନ୍ତି ବହୁତ ପ୍ରକାର ସବୁ କାଉନସିଲିଂ ମୁଁ କରେ ମଧ୍ୟ କିଏ କ'ଣ ପଚାରନ୍ତି ବୋଲି ମୁଁ ସେଥିପାଇଁ ରାତି 12ଟା 11 ରାତି 10ଟା ପରେ 10ରୁ 12ଟା ପର୍ଯ୍ୟନ୍ତ ପଚାରିଥାଏ ବହୁତ ଲୋକଙ୍କ ଡିସ୍କସନ୍ ହୁଏ ତମେ ଯଦି ତମର କିଛି ଡାଉଟ୍ ଥାଏ ପଚାରି ପାରିବ
ମୋର
ମର୍ଣ୍ଣିଂରେ
ଗୋଟେ क्वेश्चन थिला मते एपर्यंत एनरोलमेंट नंबर मोर किछि आसीनी मेल को नाही मते स्टडी मटेरियल मिलिछि तो मु कोठी कोन केमती जोगाजोग करले सेटा पाई परि मते के गाइड कर परिबे जे भी होस्ट।
ତମର ସେଣ୍ଟରକୁ ଯିବାକୁ ପଡ଼ିବ
अच्छा
ତାଙ୍କୁ କହିଲେ ସେ ତମକୁ ବ୍ୟବସ୍ଥା କରିଦେବେ
अच्छा अच्छा ठीक अच्छे सर।
ତମର ସେଠି ଆମେ କମ୍ପ୍ଲେନ୍ ପାଉଛେ ମାନେ ବହୁତ ଲୋକ ମାନେ ପାଆନ୍ତିନି ସାହାଯ୍ୟ ବେଶୀ ପାଆନ୍ତିନି ବୋଲି କହନ୍ତି କିନ୍ତୁ ତୁମେ ରାଇଟ୍ ମ୍ୟାନ୍ ଯିବ ତାହେଲେ ପଚାରିବ ସବୁ ସେ ତାଙ୍କୁ ୟୁ ମିଟ୍ ନନ୍ଦବାବୁଙ୍କୁ ପଚାରି ପାରିବ ନହେଲେ ପଚାରି ପାରିବ ସେ ଯେଉଁ ଜେନା ପ୍ରଭାତ ଜେନା ପଚାରି ପାରିବ ସେ କହିଦେବେ ନହେଲେ ଭଲ ଅକୁଳ ସାହୁ ଅଛନ୍ତି ଜଣେ ତାଙ୍କୁ ପଚାରିଲେ ସେ ବି ସାହାଯ୍ୟ କରିବେ ଏମାନେ ସବୁ ଦେ କ୍ୟାନ୍ ହେଲ୍ପ ୟୁ ଆମର ଅଛନ୍ତି ଅନ୍ୟମାନେ ବି ତାଙ୍କୁ ପଚାରିବ ଯଦି ତୁମେ ମୁଁ ଜାଣିନି ସମସ୍ତଙ୍କ ନାଁ କିଛି କଲ କେମିତି ପଚାରିବ ସେ ବି ଲୋକ ସାହାଯ୍ୟ କରିବେ କିନ୍ତୁ ତୁମକୁ ଯିବାକୁ ପଡ଼ିବ କହିଲେ ସେ କରିଦେବେ ସବୁ ହେଲା
आज्ञा धन्यवाद।
ଆଉ କ'ଣ କହିବ କହ
आ,
ଆରେ ରୁଚା ଯେଉଁ ଝିଅଟି ରୁଚା ଡକ୍ଟର ରୁଚା ଅଛ କି
हाँ सर नमस्ते सर।
ତମେ କ'ଣ ତମର କ'ଣ ମତେ ହ୍ୱାଟ୍ ଇଜ୍ ୟୋର କୋଉଠୁ ଆସୁଛ ତୁମେ କୋଉଠୁ
सर मो घर बरिगुमा कोरापुट सर मु आयुर्वेदिक डॉक्टर।
ଓ କୋରାପୁଟ ବରିଗୁମା ରାଇଟ୍ ହଁ ଆଇ ହାଭ୍ ସିନ୍ ଦ୍ୟାଟ୍ ପ୍ଲେସ୍ ଆଚ୍ଛା ଆଚ୍ଛା ବରିଗୁମା ତମେ କ'ଣ ଡକ୍ଟର ଇନ୍ ହ୍ୱାଟ୍
मु आयुर्वेदिक डॉक्टर सर।
ଓ ଗୁଡ୍ ତା ନମ୍ବର ନ ରଖିବାକୁ ପଡ଼ିବ ମତେ ତୁମେ ତୁମ ନମ୍ବରଟା ମତେ ଦବ ତୁମେ
ठीक
ହେଲା
अच्छे सर मु आपको व्हाट्सएप कर देबे सर आपन
ହଁ
नंबर
ହଁ
मो
ସେ
पाखे
ଆୟୁର୍ବେଦିକ
अछि
ଲୋକ
सर।
ତମକୁ ପଚାରିବାକୁ ପଡ଼ିବ ତମେ ଆୟୁର୍ବେଦିକ କେବେ ପାସ୍ କଲ
सर 23 रे पास करती सर मु।
ମୋର ଗୋଟେ କୋଶ୍ଚିନ୍ ତମକୁ ତମେ
हाँ
ଆୟୁର୍ବେଦିକ
सर
ଡାକ୍ତର ତୁମେ ସାଇକୋଲୋଜି କାଇଁ ପଢୁଛ
सर मते साइकोलॉजी रे इंटरेस्ट अछि सेटा होई सर।
ଓ ଗୁଡ୍ ଭେରି ଗୁଡ୍ ଆଚ୍ଛା 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 ମୁଁ ତ ସେୟା କହୁଥିଲି ବହୁତ ଲୋକ ଭାବି ଭଲ ପାଆନ୍ତି ଇଣ୍ଟରେଷ୍ଟିଂ ବୋଲି ୟୁ ରିଡ୍ ସାଇକୋଲୋଜି ୟୁ ୱିଲ୍ ଏନ୍ଜୟ
पीजी डिप्लोमा इन मेंटल हेल्थ भी करथिली सर लास्ट ईयर 1 ईयर रो कोर्स।
ହଁ
हाँ सर
ଆଚ୍ଛା ଆଚ୍ଛା କ'ଣ ମେଣ୍ଟାଲ କରିଥିଲ କ'ଣ
पीजी डिप्लोमा इन मेंटल हेल्थ।
ହେଲେ କରିଛ
हाँ सर
କୋଉଠି
इग्नोर है सर।
ଇଗ୍ନୋର କରିଛ
हाँ सर
ଆଚ୍ଛା 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 ଆଉ ଭଲ ଭଲ ମାନେ ସାଇକୋଲୋଜି ତୁମର ଏତେ ସ୍ନେହ ଅଛି ସାଇକୋଲୋଜି ପାଇଁ ୟୁ ଲାଇକ୍ ସୋ ମଚ୍ ଗୁଡ୍ ଦେନ୍
हाँ सर
ଜେମ୍ ଫ୍ରମ୍ କୋରାପୁଟ ଅଲସୋ ବାଲିଗୁଡ଼ା
कौन सर सॉरी सर क्लियर सुनाई।
नहीं जेरम फ्रॉम व्हिच प्लेस बालीगुड़ा में
आई एम फ्रॉम बालीगुड़ा सर।
କୋରାପୁଟ
ବାଲିଗୁଡା ସାର୍।
ଏଟା କଣ କୋଉଠି ଏଟା କୋରାପୁଟ ନୁହେଁ?
ବାଲିଗୁଡା ସାର୍, କନ୍ଧମାଳ।
ଓ କନ୍ଧମାଳ ଏପଟେ, ଆଚ୍ଛା ଆଚ୍ଛା କନ୍ଧମାଳ ରାଇଟ୍, ଆଚ୍ଛା 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 ମୋର ଆଇ ହାଭ୍ ନୋ ଆଇଡିଆ। କନ୍ଧମାଳ ରହୁଛ କଣ ବାଲିଗୁଡା ନା କୋଉଠି ରହୁଛ?
ମୁଁ ବାଲିଗୁଡା ରହୁଛି ସାର୍, ବର୍ତ୍ତମାନ ଏଇଠି ମୁଁ ପ୍ଲେସମେଣ୍ଟ ହେଇଛି। ମୁଁ ତା ପୂର୍ବରୁ ରାଇକିଆ କନ୍ଧମାଳରେ ହିଁ ମୋ ପ୍ଲେସମେଣ୍ଟ ଥିଲା, କିନ୍ତୁ ଏବେ ବର୍ତ୍ତମାନ ମୁଁ ବାଲିଗୁଡାରେ ଅଛି ସାର୍।
You are placed as in which post?
ଆଜ୍ ଏ ପ୍ରିଷ୍ଟ।
ଆଚ୍ଛା ଆଚ୍ଛା
ଏଇଟା ମୋ ପାଇଁ ଗୋଟେ ବହୁତ ହେଲ୍ପଫୁଲ ହେବ ସାର୍, କାରଣ ଆଇ ହାଭ୍ ଟୁ କାଉନ୍ସିଲ ନମ୍ବର ଅଫ ପିପଲ।
ଆଚ୍ଛା ଭେରି ଗୁଡ୍।
ହଁ
ଆଚ୍ଛା ଓକେ ୟୁ ଆର୍ ଅଲ୍ ବିଗ୍ ପିପୁଲ ସୋ ବେଟର
ଏବେ
ୟୁ ଅଲସୋ।
ସାଇକୋଲୋଜିର ଇମ୍ପୋର୍ଟାନ୍ସ ବହୁତ ଅଛି, ତ ସେଥିପାଇଁ ପ୍ରାୟ ସମସ୍ତେ ଆୱାରନେସ୍ ବି ବହୁତ ହେଲାଣି। ଆଗରୁ ଏତେ କନସିଡର କରୁନଥିଲେ, କିନ୍ତୁ ଏବେ ଇଣ୍ଟରେଷ୍ଟିଂ ବି ଲାଗୁଛି, ସମସ୍ତଙ୍କର ଆୱାରନେସ୍ ବି ଡେଭଲପ ହେଲାଣି। ତ
ସମର୍ପିତା
ଏ- ଆଜ୍ଞା
କୋଉଠୁ ଆସୁଛ?
ଭୁବନେଶ୍ୱର ସାର୍।
କୋଉଠୁ?
ଓଲ୍ଡ ଟାଉନ୍।
ଓଲ୍ଡ ଟାଉନ୍। ଆଚ୍ଛା ତମକୁ ଯଦି
ଅକୁପେସନାଲ ଥେରାପିଷ୍ଟ। ମୁଁ ଆକ୍ଚୁଆଲି ପିଜି କରିସାରିଛି ଅକୁପେସନାଲ ଥେରାପିରେ।
ହଁ
ଆଣ୍ଡ ମୁଁ ଯୋଉ ମୁଁ ଅଟିଷ୍ଟିକ୍ ଆଉ ସେନ୍ସରି ଇଣ୍ଟିଗ୍ରେଟେଡ୍ ଯୋଉ ଡିସଫଙ୍କସନ୍ ଛୁଆଙ୍କୁ ଦେଖେ, ତ ମୋତେ ଲାଗେ କି ସେଥିରେ ବି ସାଇକୋଲୋଜି ଯେମିତି ବହୁତ ପାର୍ଟ, ମାନେ ବହୁତ ଇନଭଲଭମେଣ୍ଟ ଅଛି, ବହୁତ ଦରକାର ମୋତେ ଜାଣିବା, ସେଥିପାଇଁ ମୁଁ ଜଏନ୍ କଲି।
ଭେରି
ଆଣ୍ଡ
ଗୁଡ୍ ଭେରି
ପ୍ୟାରେଣ୍ଟ
ଗୁଡ୍।
କାଉନସିଲିଂ, ଅଲ୍ ଦୋଜ୍ ଥିଙ୍ଗସ୍। ଆଉ ନିଜ ପାଇଁ ବି ଡେ ଟୁ ଡେ ଲାଇଫରେ ଆମକୁ ବି ନିଜକୁ ସାଇକୋଲୋଜି ମାନେ ଦରକାର ପଢିବା ଆଉ ଜାଣିବା ସେ ବିଷୟରେ।
ଭଲ ଭଲ ଭେରି ଗୁଡ୍ ଭେରି ଗୁଡ୍ ଭେରି ଗୁଡ୍।
ସାର୍ ମୋର ଗୋଟେ
ସାର୍
କ୍ୱେଶ୍ଚନ୍
ଏଇଟା
ଥିଲା
ଏବେ
ସାର୍।
ମଷ୍ଟ ସବଜେକ୍ଟ ସାର୍ ସମସ୍ତଙ୍କ ପାଇଁ। ଆଗରେ ଆମେ ଜାଣିଥିଲୁ ଯେ earlier we knew that ବଡ ଲୋକମାନଙ୍କୁ ଯେ ଏଟା ସବୁ ଆବଶ୍ୟକ ଥିଲା ସେ ସବୁ, କିନ୍ତୁ now ଭେରି ବିଗିନିଂ ଫ୍ରମ ଦ ଚାଇଲ୍ଡହୁଡ ଏଟା ସବୁ ଆବଶ୍ୟକ। ଏବେ ସବୁ ଛୋଟ ଛୋଟ ବୟସର ସବୁ ପିଲାମାନେ ଏଇ ସବୁ ସମସ୍ତଙ୍କୁ ଏବେ ଇଟ୍ ଇସ୍ ଏ ମଷ୍ଟ ସବଜେକ୍ଟ କାଉନସିଲିଂ ପାଇଁ, ସବୁ କିଛି ପାଇଁ। ତେଣୁକରି ଆଟ୍ ପ୍ରେଜେଣ୍ଟ ରାଇଟ୍ ନାଓ ଏଟା ଭେରି ମଚ୍ ଡିମାଣ୍ଡେଡ୍ ସବଜେକ୍ଟ। ହେଲେ ଏଇଟା ହେଲେ ଆଟଲିଷ୍ଟ ଆମେ ଆଜି ଆମମାନଙ୍କର ସମର ପିତା ଯିଏ ଦିଦି କହୁଥିଲେ, ସେଇ ମଚ୍ ଆମକୁ ନିହାତି ଆବଶ୍ୟକ ଜଣକ ନିଜକୁ ବୁଝିବା ପାଇଁ, ଅନ୍ୟମାନଙ୍କୁ ବୁଝିବା ପାଇଁ, ଫର୍ ଏ ବେଟର ଲାଇଫ।
ହଁ ଠିକ୍ ଅଛି। ମୁଁ ସବୁ ବର୍ତ୍ତମାନ ଆମ ସ୍କୁଲରେ ସବୁ କାଉନସିଲିଂ ସବୁ ଖୋଲିବ ବୋଲି ମୁଁ ସବୁ ଟିଚରମାନଙ୍କୁ କାଉନସିଲିଂ ଟ୍ରେନିଂ ଦିଏ, ବୁଝିଲ କେମିତି କାଉନସିଲିଂ ହେବ ତା ଟ୍ରେନିଂ ବହୁତ ଦିଏ ମୁଁ। ତେଣୁ ତୁମକୁ ବି କେତେବେଳେ ବି ଗୋଟେ ମିଳନ୍ତା ଅକେଜନ୍ ତୁମକୁ ସବୁ ବତି ଦିଅନ୍ତି କେମିତି କାଉନସିଲିଂ କରିବ ବୋଲି। କାଉନସିଲିଂ ହାଜ୍ ମଚ୍ ସ୍କୋପ୍, ଆଉ ବେଶୀ ଇଣ୍ଟରେଷ୍ଟିଂ ମଧ୍ୟ। ଭେରି ଗୁଡ୍। ସମର୍ପିତାକୁ ପଚାରିଲି କୋଶ୍ଚିନ୍ କାହିଁ ସେ କହୁଥିଲା, ତା ସ୍ୱର ଶୁଣିଲି ମୁଁ। But I was asking, she was keeping quiet. ଆଚ୍ଛା କିରଣ କୋଉଠୁ? ବୋଧେ I asked you probably earlier.
ସାର୍ ମୁଁ
ସାର୍ କଣ ପଚାରିଥିଲେ
ସାର୍
ମତେ
ଗୋଟେ
ମୁଁ
କ୍ୱେଶ୍ଚନ୍ ଥିଲା ସାର୍।
ନା କୋଉଠୁ?
ସାର୍
କିରଣ କୋଉଠୁ?
ସାର୍ ମୁଁ ତ ବେସିକାଲି ସାର୍ ବରଗଡ଼ରୁ ସାର୍। ବର୍ଷା ମୁଁ ଏମ୍ସରେ ଅଛି ସାର୍, ୱାର୍କିଂ ଅଛି ଏମ୍ସରେ ଭୁବନେଶ୍ୱର ସାର୍, ଏମ୍ସ
କୋଉଠି?
ଭୁବନେଶ୍ୱରରେ ସାର୍।
ଆଉ ଟିକେ ଧୀରେ ଧୀରେ କହ, ଟିକେ ମୁଁ ଶୁଣିପାରିନି। ହଁ କହିଯାଉଥିଲେ।
ସାର୍ ବେସିକାଲି ସାର୍ ମୁଁ ବରଗଡ଼ରୁ ସାର୍ ବିଲଙ୍ଗ କରୁଛି,
ମୁଁ
ବରଗଡ଼ରୁ ସାର୍।
ବରଗଡ଼ କହୁଥିଲ ବୋଧେ ବରଗଡ଼ ନୁହେଁ କି?
ହଁ ସାର୍ ବର୍ଷା ମୁଁ ଏମ୍ସ ସାର୍ ଏବେ ୱାର୍କିଂ ଅଛି ସାର୍ ଏମ୍ସରେ ଭୁବନେଶ୍ୱରରେ।
ଆଚ୍ଛା ଆଚ୍ଛା
ଆଉ ସାର୍ ମୋର ବ୍ୟାକଗ୍ରାଉଣ୍ଡ ସାଇକୋଲୋଜି ସାର୍।
ଆଚ୍ଛା ଆଚ୍ଛା ଆଚ୍ଛା
ମୋର ସାର୍ ବ୍ୟାଚଲର ଡିଗ୍ରୀ ସାର୍ ମାନେ ସାଇକୋଲୋଜି ସାର୍ ଥିଲା ସାର୍।
ଆଚ୍ଛା ଆଚ୍ଛା ଆଚ୍ଛା। ଭାଗ୍ୟଶ୍ରୀ କୋଉଠି ଅଛ?
ସାର୍ ମୋର ଭୁବନେଶ୍ୱର।
ଭୁବନେଶ୍ୱରରେ ତୁମେ?
ହଁ ଭୁବନେଶ୍ୱରରେ ଉତ୍ତରା ଓଲ୍ଡ ଟାଉନ୍ ଏପଟକୁ।
ସବୁ ଓଲ୍ଡ ବାଲା ନ୍ୟୁ ଟାଉନ୍ ବାଲା କାହିଁ ମୋ ଘର ପାଖେ କେହି ନୁହନ୍ତି। ମୁଁ ମିଡ୍ ଟାଉନରେ ମୁଁ। ହଉ ଆଚ୍ଛା ତମେ ଯୋଉ କାହିଁ ପଢିଲ, ସେ ଇଣ୍ଟରେଷ୍ଟିଂ ବୋଲି ପଢିଲ ନା କଣ କରୁଛ କିଛି?
ସାର୍ ମୋର ବିଏସସି ନର୍ସିଂ ବ୍ୟାକଗ୍ରାଉଣ୍ଡ। ମୁଁ ସିଭିଲ ସର୍ଭିସ ପାଇଁ ପ୍ରିପେୟାର କରୁଛି, ଯେ ସେଥିରେ ସାଇକୋଲୋଜି ଅପସନାଲ ରଖିଛି। ଗୋଟେ
ଓ
ମେନ୍ସ
ଗୁଡ୍।
ଦେଇସାରିଛି, ପ୍ରିଭିୟସ ଇୟର ମେନ୍ସଟା ସାଇକୋଲୋଜିରେ।
ଓ ଭେରି ଗୁଡ୍। ତମର ବିଏସସି ନର୍ସିଂ କୋଉଠି କଲ?
ବିଏସସି ନର୍ସିଂ ହାଇଟେକ୍ କଲେଜ ଅଫ୍ ନର୍ସିଂ ଭୁବନେଶ୍ୱର।
ହାଇଟେକ୍ କଲ, ଆଚ୍ଛା ଆଚ୍ଛା ଆଚ୍ଛା। ନର୍ସିଂରେ ମୁଁ କ୍ଲାସ୍ କରୁଥିଲି ଏସ୍ପିରେ। ଆଚ୍ଛା ଭେରି ଗୁଡ୍। ଓ ଲଟ୍ ଅଫ୍ ପିପୁଲ, ଗୁଡ୍ କ୍ୱାଲିଟି, ଭେରି ଭେରି ଗୁଡ୍। ଆଚ୍ଛା ଆଉ ପୁଣି କଣ ସବୁ କିଏ ସବୁ ଅଛ ସବୁ? ମାନେ ମତେ ଲାଗୁଛି ଏଇ ସବୁ there are so many big people and I have to keep your contact numbers because you will be helpful to me. ଦାଶରଥୀ କୋଉଠି ଅଛ? ଦାଶରଥୀ ଦାଶରଥୀ କୋଉଠି ଅଛ?
ସାର୍
ଦାଶରଥୀ
ମୋର ଗୋଟେ କ୍ୱେଶ୍ଚନ୍ ଥିଲା ସାର୍।
କୋଉଠି? ହ୍ୟାଲୋ। ଶୁଣି ପାରୁନ ଦାଶରଥୀ? ଆରେ କ୍ଷଣପ୍ରଭା
Yes, sir.
ତୁମେ ପୁଣି କୋଉଠି ଆସୁଛ? କୋଉଠି ଅଛ?
Sir, ମୁଁ ଯାଜପୁର ଘର ମୋର ଯାଜପୁର ବାକି ମୁଁ ଏବେ ସୁନ୍ଦରଗଡ଼ DHH ରେ ପୋଷ୍ଟେଡ।
କଣ କରୁଛ?
Sir, ମୁଁ ପ୍ରୋସ୍ଥେଟିଷ୍ଟ and orthotist.
ଆଚ୍ଛା, ଓ ଗୁଡ୍। Oh, so many big people are here. ମୁଁ ତ ତମକୁ ସବୁ କହିଲା ବେଳକୁ ମୋତେ ଲାଗୁଛି ଯେ I am a small person because you are all skillful in different faculty, different areas. ଭଲ ହେଲା, we will be keeping in contact. ମତେ ତୁମେ ସମସ୍ତଙ୍କ ଡାଉଟ୍ ଯାହା ପଚାରିବ ମତେ କହିପାରିବ, ମୁଁ ନମ୍ବର ଦେଇଛି। We will be trying to be clear in concepts, right? ଆଉ କଣ ପଚାରିବ ନା ପଳେଇବା?
ସାର୍ ଗୋଟେ ମୋର କ୍ୱେଶ୍ଚନ୍ ଥିଲା ସାର୍।
ହଁ କହ।
ସାର୍ ଏବେ ସାର୍ ଇସିର ଯୋଉ ରେଗୁଲେସନ୍ ବାହାରିଛି ଇସିର ସାଇକୋଲୋଜି ସାର୍ ଯୋଉମାନେ ଡିଷ୍ଟାନ୍ସ କରୁଛନ୍ତି ତାଙ୍କର ସାର୍ ଭ୍ୟାଲିଡ୍ ହେବନି ଫ୍ୟୁଚର ପାଇଁ?
ଶୁଣ ତମେ କିଏ କହୁଛ କହିଲ?
ସାର୍ କିରଣ କହୁଥିଲେ ସାର୍।
ହଁ କିରଣ, ଟିକେ ସ୍ଲୋଲି କହିଲ, ଧୀରେ ଧୀରେ କହିଲ। ମୁଁ ଟିକେ ଏଇ ଗୋଟେ କଣ ଗୋଟେ ସାଉଣ୍ଡ ଆସୁଛି ଗୋଟେ
ଓକେ ସାର୍। ସାର୍
ହଁ କହ।
ଏବେ ସାର୍ ଇସିର ଯୋଉ ନୂଆ ଗାଇଡଲାଇନ୍ ବାହାରିଛି ସାର୍, ଏବେ ସାର୍ ଯୋଉ ଇସିର ଯୋଉ ନୂଆ ଗାଇଡଲାଇନ୍ ବାହାରିଛି, ହ୍ୟାଲୋ।
ନୂଆ ଗାଇଡଲାଇନ୍ ବାହାରିଛି ୟୁଜିସିର।
ହଁ ସାର୍, ଯୋଉ ସାଇକୋଲୋଜି ଉପରେ ଯୋଉମାନେ ସାର୍ ଡିଷ୍ଟାନ୍ସ ଯୋଉମାନେ ସାଇକୋଲୋଜିରେ ମାନେ
ହଁ
ଇଏ କରୁଛନ୍ତି ତାଙ୍କର ସାର୍ ଭ୍ୟାଲିଡ୍ ହେବନି କି?
ହଁ ହବ ତ। ଆରେ ଡିଷ୍ଟାନ୍ସ କୋର୍ସରେ
ସେମିତି
ଲୋକ ଡିଷ୍ଟାନ୍ସ କୋର୍ସରେ ସାଇକୋଲୋଜି ପାସ୍ କରିକି ଲେକ୍ଚର ଅଛନ୍ତି। ଏଇଟା ଆମର ଗୋଟେ ପାଇଛି ଏବେ
ସାର୍
ଖୋର୍ଦ୍ଧାରେ।
ସାର୍ 2025 ସାର୍ ଜୁଲାଇ ସେସନ ସାର୍ ଭ୍ୟାଲିଡ୍ ହେବନି କହିକି ମାନେ ନୋଟିସ୍ ବାହାରିଛି ସାର୍ ଇସିର।
ନାଇଁ ସବୁ ଡିଷ୍ଟାନ୍ସ ସାଇକୋଲୋଜି କଣ ଇଗ୍ନୋରରୁ ପଢିକି ଲୋକମାନେ ଦେହର ଗେଟିଂ ଭଲ ଅଫର ପାଉଛନ୍ତି, କିଛି ଅବସ୍ଥା ନାହିଁ।
ହଁ ସାର୍,
କାରଣ
ସାର୍
ଇଗ୍ନୋର ତ
ନୋଟିସ୍ ବାହାରିଛି ସାର୍। ସାର୍ ସାର୍ ନୋଟିସ୍ ବାହାରିଛି ସାର୍ ସେମିତିଆ ଇସିର।
ହଁ ବାହାରିଛି। କିନ୍ତୁ କଣ ବାହାରିଛି?
ମାନେ ସାର୍ ଆମର ଯୋଉ ସାଇକୋଲୋଜିଷ୍ଟ ହେଲେ କାଉନସେଲିଂ ସାଇକୋଲୋଜିଷ୍ଟ ହେଲେ ତାଙ୍କର ସାର୍ ମାନେ କ୍ୱାଲିଫିକେସନ ମାନେ ସେମାନେ ରେଗୁଲାର ଡ୍ୟୁଟି ମାନେ କୋର୍ସଟା କରିଥିବା କଥା ସାର୍।
ଓହୋ, ଏତେ ମଟେରିଆଲ ମୋ ହ୍ୱାଟ୍ସଆପରେ ପଠେଇଲ ଆଜି ଦେଖିବି।
ପଠେଇଦେବେ ସାର୍, ଆପଣ ପଠେଇଦେବେ।
ନାଇଁ କିନ୍ତୁ ମୁଁ ଜାଣିଛି ତୁମର ଯେତିକି ଯୋଉ ତୁମର ପାସିଂ MA ଇନ୍ ରେଗୁଲାର କୋର୍ସ, ପାସିଂ MA ଇନ୍ ଡିଷ୍ଟାନ୍ସ କୋର୍ସ, ଦ୍ୟାଟ୍ ଇଜ କାଉଣ୍ଟିଂ ସେମ୍। କିନ୍ତୁ
ହଁ
ଏହା
ସାର୍,
ଟିକେ
ଏବେ ସାର୍
ସବୁ
ଏବେ
ସମାନ।
ରିସେଣ୍ଟଲି ବାହାରିଛି, ଏବେ ରିସେଣ୍ଟଲି ବାହାରିଛି।
ହଁ
ଅଗଷ୍ଟରେ ବାହାରିଛି ସାର୍, ଅଗଷ୍ଟରେ।
ଆଚ୍ଛା ଆଚ୍ଛା, ସବୁ ସମାନ, କିଛି ବ୍ୟସ୍ତର ନାହିଁ ହେଲା।
ସାର୍
ଆଉ କଣ ସବୁ କହିବ ସବୁ? ଏନିଥିଙ୍ଗ ଆଉ କିଏ କହିବ? ସବୁ ପଇଲେଣି ବୋଧେ ନା ଅଛନ୍ତି ଆଉ? କ୍ଷଣପ୍ରଭା କିଏ ନାହ କି? ମୁଁ ତ ପଚାରିଲି କିଏ ଶୁଣିଲାନି ସେ।
ଅଛୁ ସାର୍, ଅଛୁ ନାଇଁ?
କଣ ହେଲା ତୁମ କଥା? ସେ କଣ କୋଉଠୁ କଣ ଆସିଛ ତୁମେ? ତମ ଘର କୋଉଠି? ଆଁ କ୍ଷଣପ୍ରଭା କୋଉଠୁ ଆସିଛ?
ଆଜ୍ଞା ସାର୍, ମୁଁ
ଭୁବନେଶ୍ୱରର?
ଯାଜପୁରରୁ। ନା
ଯାଜପୁର।
ଯାଜପୁରରୁ।
କଣ କରୁଛ କାମ?
ସାର୍, ମୁଁ DHH ସୁନ୍ଦରଗଡ଼ରେ ଅଛି ପ୍ରୋସ୍ଥେଟିଷ୍ଟ ଅର୍ଥୋଟିଷ୍ଟ।
ହଁ ସେଇ ସେଇଟା ହଁ, ମୁଁ ତ ପଚାରିଲି ତୁମେ, ମୁଁ ଭୁଲିଗଲି
ଆଜ୍ଞା
କାଲି
ଆଜ୍ଞା
ଦେଖିଲି। ରାଇଟ୍
ଆଜ୍ଞା
ହଁ
ଆଜ୍ଞା।
ହଁ, ପ୍ରୋସ୍ଥେଟିକ୍ ଅଛ, ହଁ ମୁଁ ଜାଣିଲି। ହଁ ଭଲ ହେଲା। ଇଏ ଗୋଟେ BSc ନର୍ସିଂ କରିକି ଆସିଛି, ସିଏ ଗୋଟେ ଆୟୁର୍ବେଦିକ ଡକ୍ଟର ଆସିଛି, ଇଏ ଗୋଟେ ଗୋଟେ ଭଲ ଇଏରେ ଆସିଛି। ଭଲ ଭଲ ସବୁ ପିଲା ସବୁ ଆସିଛ, ସବୁ ଭଲ। You are on ମାନେ ଖାଲି ସାଇକୋଲୋଜି ବହୁତ ଆସିଛ। You love psychology, so you have come to psychology.
Yes, sir.
Good. Psychology is always lovable. ଆଚ୍ଛା, ଭେରି ଗୁଡ୍। ଆଉ କଣ ପଚାରିବ କିରେ ନା ପଳେଇବା? ମତେ ଲାଗୁଛି you want to get me continuing here. So ask me anything. I'll be happy if you ask anything. ଖାଲି ବସିଲେ କଣ ହବ?
ଆପଣ ଯୋଉ କଣ୍ଟାକ୍ଟ ନମ୍ବରଟା ଦେଇଛନ୍ତି ସେଟା ହ୍ୱାଟ୍ସଆପ୍ ର କି? ସେଟା ହ୍ୱାଟ୍ସଆପ୍ ବି ଅଛି କି?
व्हाट्सएप मोर तो व्हाट्सएप सब व्हाट्सएप जो गोटे नंबर मोर
ठीक अच्छे सर ठीक अच्छे
मोर व्हाट्सएप ए हाई कर जान जी मु आसला कि
आज्ञा
नहीं
आज्ञा सर हाँ
अच्छा मत जो व्हाट्सएप को तुम ना देखिए पठेब
निश्चिंत निश्चिंत
ना जापर किए कौन कला बोली बेले इग्नोर करदेवी
आज्ञा आज्ञा
अच्छा आउरी सब किए किए अच्छा सब जानी पारुनी देयर आर मेनी पर्सन स्टिल भल होला तुमर शुण आउ थे तो कही दउची मु आमे सब पढ़ला बेले ऑफलाइन रे बेटर हुए ऑफलाइन रे क्लैरिटी हुए तुम पढ़ले सब क्लीयरली बुझी पारिबो ऑनलाइन रे डिफिकल्ट हुए तेणु ऑनलाइन डिफिकल्टी होउथिबो बुझी पार नथिबो तेणु मते पचारले मु क्लारिफाई करदेबी बुझल नहीं जेबे स्कोप मिलिबो ऑफलाइन पाई बेले बेले दियंती गोटे क्लास ऑफलाइन दियंती जदि दियंती केतेबेले सब तक डाउट क्लियर करदेबी सेठी हैला ओके let us take a leave. So also I am equally affected. I don't want to leave you all. I want to continue talks, but it is 2:25. I mean 2:30. Elani adho delani jari. Let us disperse. Thank you all very much.
थैंक यू सर
We'll see you tomorrow. Thank you.